right. My name is Nana Adumasamo Jr. and I'm a student at Ghana Communication University. And today I am coming to build 8 by 1 multiplexer using the Logism software. And before I build it, this is how I'll be working it on a sheet of paper before I present it. Laptop. Okay, that's my laptop, right? Now, so this is the piece of paper that I have here. Now it is 8 by 1. Okay, 8 by 1. 8 by 1 multiplexer, right? Yes. Okay. 8 by 1 multiplexer. Now in this case, for you to put it on a sheet of paper, there is one or two calculations that you need to do before you can actually come out with your with a successful building of the multiplexer. Now in this case, if I have 8 by 1 multiplexer, then 2n is equal to 8. All right. Now, because I have the exponent as n, I need to make sure that the exponent of 8 here, I should also equalize or make the 8 has an exponent that can be equal to the n here. So I have 2n, finding the exponent of 8 is going to be 2 raised to the power 3. All right, therefore n is equal to 3, which means that there will be 3 input lines, selection or select lines. All right, that's 3 select lines. Therefore, if I'm supposed to draw it, this is how I'm going to draw it. I have to make sure I have my my box like this. Now then I divide it by 8. So I have 1, 2, 3, 4, 5, 6, 7, 8, which I will name this one D0, D1, D2, D3, D4, D5, D6, and D7. All right. Now in this case, this is actually 8 by 1 multiplexer. Now I have an output that I call it Y, right? And my select lines or my selection lines here is 3 based on what we got. So I have my X, 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 but this one is X0, X1, and X2. So this is what I'm going to use to build my my 8 by 1 multiplexer. And after getting this one, we have to also construct the truth table. So this is the truth table. All right, so I have my truth table here. Okay, so with this truth table, I'm actually going to construct the same lines in which I'm going to get 8. 1, 2, 3, 4, 5, 6, 7, 8, right? 9, so to be 9 here. Okay, so I will divide this one into 2 equal parts, in which this side is my Y and this one here is my S0, S1, S2. Okay, so I can also divide this like this so that I have these things here. All right, now let's find the truth or the truth table for the 8 by 1 logism. Okay, so I have the 3 lines here, 3 select lines here, and have the input 8 or from D0 to D7 input, and have my output. Okay, so that is what explains multiplexer. Multiplexer means many to one. Okay, many inputs as we have one output. All right, so here if I have 0 here, okay, so I can have my 0 0. Okay, that's my binary numbers here. Okay, so I have my 1 1 here. Okay, I still have my 0 0 here. I will explain it. 0 0 and have 1 1 here, and I have 0 1 0 1 0 1 0 1. The reason why I have these binary numbers here is because now the first input is D0. You have the second one D1, D2, D3, D4, D5, D6, and D7. Now, how can I get 0 0? Now here, let me put it here. So now, if I have three selection lines here. Okay, and this one is 0. The binary number here is the binary value is 0 0 0, and this is 0. Okay, now how did I get the one here? Because here, if I have if I want to get one for the output, for the input here, or one for the input here, that's what I'm going to do. So I have one here, I have two here, and I have three, yeah, four here. Now with this four here, how will I get the one? So this is one when you are converting the binary number to base 10. Okay, so this is one, right? So I have one here. Okay, one here, and this is 0 0 because I want only 0. All right, so I'll put my one here. All right, if I want to get 2, okay, since I have 4 2 1 here, how will I get a 2? So in this case, here will be 0, here will be 1, and here will be what? 0. Therefore my 2, so I have 0 1 2. So that's the reason I have 0 1 2. Okay, if I want to get 3, okay, the 3, the same numbers I write here, then 3. So 2 plus 1 is going to give you 3. So I have 1 here, I have 1 here, then this one is 0. So that's, we have 0. Okay, we have yeah, 0 1 1. That's D3. So and so on. That's how I got up to D7. All right, very good. Now let's find a Boolean function. Okay, the Boolean function of this truth table. Now, why? Okay, why? Why here? Let me put it this way. Why here? Okay, is equal to D0. Okay, S0, S1, and S2. Okay, so here, since it is 0 0 here, this is not, this is not, this is not, right? I add it. Okay, so I have another one here. So D1, okay, X0, S1, X2. Since we have 0 0 1, so this is going to be 0 0, and I leave this one here. Okay, plus I have D2, X0, X1, X2. So 0 1 0. So that's 0 1 0 plus D3. Okay, so D0, D1, D2, D3. D3 is 0 1 1, right? So X0, X1, X2. All right, so D3 is 0 1 1. So here is 0. I leave it like that. Now plus, okay, plus D4, X0, X1, X2. So D4 is 1 0 0. Okay, so here I have 1 0 0. All right, plus D5. D5 S0, X1, X2. So D5 is 1 0 1, right? So we have 1 0 1 plus D6. Now the D6 S0, X1, X2. All right, D6. So we have 1 1 0. 1 1 0. So here is 1 1 and 0, right? And the last one is D7, X0, X1, X2. And I have that is 1 1 1. So here I will leave it like that. Okay, so in this case, okay, is I am going to implement it on the software. I'm going to implement this on the software so that at least I can build my 8 by 1 multiplexer. All right, so let me do something here. All right, so here I have my uh, that's my pin here. Okay, so I'm coming to construct 7. All right, so I have one here. Okay, so I can copy this one. All right, so I can copy this one, then I paste it. Okay, then I have let me copy it once again and then paste it. Now I have 2 here. Okay, I can paste it. So I want to build, so I'll paste it. All right, so let's see. All right, paste. So I have 1, 2, 3, 4, 5, 6, 6. Now should have 7, right? So 7, and the last one is supposed to be 8. Okay, paste, and I have my 8 here. All right, now I should also have 3 selection lines. 3 selection lines. Now the 3 selection lines, I'm also going to do it. I'm still going to bring it here. Okay, yeah. Another one, I also bring it here. Okay, and another one that is also bring it here. Right. Now, based on this here, okay, so let me put this one here. Now, based on what I have here, okay, I need to construct my what do you call it, my selection. All right, so with this selection, I can construct my selection lines here. So I have one here. Okay, so here I can my selection line. These are my selection lines. So therefore, I include my this thing. Okay, my NOT gate. Okay, my NOT gate. Then I connect it here. All right, so I can connect it on this one. Okay, so let me bring this one here small, right? All right, so the same thing that I have here, so I can copy it and I bring it here, right? The same thing here, I can also bring it here, right? So in this case, I'm going to, so this is my, what do you call it? My selection, okay, or my select lines, okay? All right. Okay, so here, the next one is to have to put my end gate there, my end gate. All right. So before I put it, let me construct my input. So this is my one input here. Okay, another input, another input, another input, right? So I'll construct all my inputs, construct all my input, right? Good, 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 very good, very good, very good. Now, the goal is that at the end of the day, there should be a data flow. That is the vision. That at the end of the day, there should be a data flow. Okay, yeah, there should be a data flow. Now, so let's continue. All right, now that I have my data, okay, now that I have my data here, my input and my selection line, okay, I am going to connect my end gate. So I click on my end gate. So I have one here. So I need to implement 8. Okay, 8 end gates. So let me put it here 1, right? So here it should have the 3, what do you call it? 4, okay, 4 input. All right, should have 4 input lines here. All right, so I copy it and I paste it here, the same 4. So I have 1, okay. So let me paste it. I have 2 here. Okay, I have 3, I have 4, that's 5, right? I have 6, I have 7, okay. The last one I have 8. So that means that here I can extend it small. I can remove this one. I can extend this one. I can extend this one. I can extend this one, right? So I am extending all 2. So let me extend this one too. Extend this one. Extend this one. All right. So I am extending it so as to get the lines connected well, so that I don't encounter any error. I just want to do it once and for all, so that I finish with it, then I collect my marks. Oh my god. All right, now the next one is going to be the output. Okay, I've already told that multiplexer, it has one output, right? So I can divide it. This one is 3, this one is 3, so I can just put it somewhere here. All right, then that's 1 2 3 4 5 input. I need 4, only 4, right? So I make it 4 here. Now I connect it with my so that is my pin, right? So I add a pin here. Okay, so this is the connector. Okay, this is actually going to make me know whether data is going through or not. All right, so first of all, what I'm going to do is that I'm going to connect my end gate, right? So here I have this one here, right? So I can connect this one here, right? Very good. I have this one. Okay, I can connect this one here, right? Good. Very good. I have this one here. I can connect this one here. Fantastico. Okay, so this one should be 8, right? Okay, so 8. All right, so let me put this one here, this one here, this one here. All right, so supposed to be 8, right? So I have one here, 2 here. Okay, so I have my 3 here, right? Good. Now let me connect the other one here. Okay. All right, so let me connect it here. Okay, so gradually I am doing the connection, right? All right, so here I connect it to this one. Okay, then the next one here I connect it to the other one here. I see. Oh my goodness. So I connect this one to the other one. So left last one, I connect my end gates to the OR gates. Wow, my God, my God, my God. Wow. So I have my the connection here. Now I'm just building it. I'm building 8x1 multiplexer. Right. So let me connect my D1. So this is X, this is D1, sorry, D0, D1, D2 up to D7. So this is this one is particularly D0, right? So here I have my D1, right? So I connect my D1, I have my D2, okay, D2, I have my D3, okay, I have my D4, right? So this is D4, I have my D5, D5, oh, I can't believe my break. I have D5. And I went to D6. D. Hey, that's my mistake. Okay. D6. Alright. Now, left the last one. 1 here, 2 here, 3 here, 4 here, 5 here. Alright. 1, 2, 3, 4, 5, 6, 7, 8. I think I have 1, 2, 3, 4, 5, 6, 7, 8. So which one did I connect? So I've connected this one. I've connected this one. I've connected this one. I have connected this one. I've connected this one too. I've connected this one, and I've connected this one, and the last one I have connected it. That's it. All right. So in this case, now we are going to use the Boolean function to actually connect it. Okay. Now it left it to the selection gate. I'm done with the input. So I'm done with the first input. This is the first input. This is the second input. The third input. Now let's go to the selection line. So this is one here. I have selection 1, 2, 3. Now this is actually called S0, right? S0. This is called S1 and X2. All right, so the first one on the table, on the truth table, we have 0, 0, 0. So that means that if I come to the end gate here, okay, this one is supposed to be 0, right? So let me connect it here. Okay, so I have to extend my my lines. Let me extend it here. Okay, I have to extend it to this side. Okay, I have to extend this one here. Okay, I have to also extend this one here. Okay, so now I have my my zeros and ones here. All right, this one is 0, 0, 0. So this one is 0. Okay, 0. This one is also 0, and this one is also 0. Okay, so that means that if I have 0, 0 and I connect this one, all right, so here if I open, okay, now you can see that now data is flowing through. All right, data is flowing through. Oh my gosh. Data is flowing through. So the second one is 0, 0, 1. So this one is going to be 0, 0, 1. This is 1, right? Now let's try it and see. Okay, so the second one here, if the 0, 0, 1 here, then I have opened it. So that means that the D1, this is D0, D1. So this D1 is actually going to work through. So data is passing through. Say, please, I hope you can see it. My data is passing through. Oh my God, this one is too circumspect. All right, now the next one here is actually 0, 1, 0, right? So this one is 0, 1, 1 here, and 0. Okay, that is 0, 1, 0. All right, let's see if that one also works, right? Now it is 0, 1, 0. That means that the third one should also work. Oh my gosh. Monguta. All right, so let's continue. Now we construct it so that after I just do the experiment, then you move on. All right, so the third one, that is the fourth one. That D3 is 0 and 1, right? This one is 0. Okay, this one is 1. This one is 1, 1, and this one is also 1. All right, 1, 1. Okay, 1, 1. All right, let me zoom it out more. All right, now let me try it and see if it works. All right, so 0, 1, 1, 0, 1, 1. All right, so that's the third one. All right, so data passes through, data goes through it, data goes through it. All right, now let me construct the other one here. Now the fourth one, that is D4. Okay, D4 is 1, 0, 0. Okay, so this is 1. Okay, and this is 0. Okay, and this is also 0, right? Very good. Okay, let me try it. So here 1001, this is 0 and this is 0. So you can even see that this one is working. All right, it is working. All right, Now, I hope so you can see it's working. It's working perfect and majestically. All right, now let me continue with the fifth one. That's 101, right? So this one should be one. Okay, one. All right, zero, 10, and this should be one. Okay, I'm testing it as I am doing so that I don't waste much time. Say, all right. So here, that's 1 0 1 1 0. Okay, 0 1 1 0. 1 0 1. Is it 1 0 1? That's 1 0 1. Right, 1 0 1. So that's the fifth one. So you can see it is working. It is working majestically. Okay. I can see. All right. Now let's move to the next one here. That is the fifth one. Yeah, the sixth one is 1 1 0. Okay. So this is one, right? This is one. Okay. And this is 0. You can see. All right. So let's work on it. So that's 1 1 0. 1 1 0. Okay. Very good. So here data is passing through. All right. Data is passing through. I'm tired. All right, the last one is the 1 1 1. All right, so this one is just very, very easy. 1 1 1. All right, so here, if I take it through, that means that 1 1 1, the last one is going to work majestically, majestically. So this is actually 8 by 1 multiplexer. All right, multiplexer. So let's see, data will pass through here. So data pass through this one, right? That's 0 1 1. So if I say 0 0 1 here, 0 0 1 here, that's D2. Okay, this one is actually going to work. All right, very good. Okay, so this is actually 8 by 1 multiplexer. See it on the screen. Okay, on the screen, that is 8 by 1. All right, so um all right, so this is how I built the 16 by 1 multiplexer using the logism table. All right, so for now, um after explaining the 8 by 1 multiplexer, this is how I also built the 16 by 1. All right, so as you can see on my interface, now I placed 16 two input AND gate, each representing one of the 16 data input. That's D0 to D15. So this is the first AND gate, and this is the second AND gate. From this side, from this side, um, from this side up to this side is another. That is the second, and this is the first AND gate. Now here, I just place them to represent one of the 16 data input. That's from D. So this is D0, D1, D2, D3, up to D15, which add up to the 16 input. Now, after doing so, I used 4 lines. 4 line, that is X0. All right, 4 line, that's X0, X1, X2, and S3 to select lines. That's the select lines. And we're connected using a combination of direct connections and NOT gate to ensure that only the correct AND gate would be activated for any selection. All right, so this is my select lines. You can see my select lines. So we have the X0, X1, X2, and S3. Okay, so that's what I said. I use the x0, x1, so this is x0, x1, x2, and x3. Okay, and these solid lines were connected using a combination of direct connection and NOT gates to ensure that only the correct lines are correct AND gates would be activated for any given selection. And the third one, and so let's look at how to implement it. For the implementation, now when x1, x3, sorry, x3 is 0, x2 is also 0, and x1 is also 0, and the last one is also 0. So here, this one, x0 is also 0, and D0 is selected. That means that this D0, when I click on it, I'm actually going to, so you can see from here, if I click on the D0 now, data pass through it, and that is the one that you are seeing as the output. All right, now let's focus on it. So when x0, x3 is selected as 0, x2 0, and the S1 is also 0, and the last one, the S0 is 1 here. Okay, that means that D1 is also selected. Okay, so if I click on that one, that means that data passes through it. Data pass through it. If I click here, okay, you can see that the data runs through it. All right, now this pattern continues until S3 is equal to 1, S2 is equal to 1, S1 is equal to 1, and S0 is equal to 1. So which means that if this place, if S3 is 1, S2 is 1, and X1 is also 1, if all are 1, that means that the last D15 is selected. So here, if I click on the D15, okay, the data passes through it. That is the 16 by 1 multiplexers. Now, all 16 AND gate output were connected to a 16 input OR gate, making sure that only the selected data input pass through to the output. And I label all input, output, and set lines for clarity. All right, so when you look at this one, you can see that there is a sense of clarity here. Everything is clear here. And after completing the connections, I tested the circuits by varying the select inputs and confirming that the correct data input always appeared at the output. So you can see from my D1 up to D15, all the data inputted here is correct, and you can see that it is actually working perfectly. All right, it's working perfectly. That is how I built my 16 by 1 multiplexer. All right, so I can say that this experience allowed me to deepen my understanding of how multiplexers operate, both theoretical and practically. Working in both 8 by 1 and 16 by 1 multiplexers gave me hands-on exposure to how digital circuits manage sections. All right, so that's how I built my 16 by 1 multiplexers, and you can see that everything is working. So if this place is 0, all right, so this is 0, 0, 0, and this is 1, right? And I click on this one, so that means that now let me see, so this one become activated, the one become activated, right? So if I click here, all right, I can see that there's an activation here. Okay, so if I click, I can see that there's an activation, something is working here. All right, okay, so if I click this one too, I can also, if I click on, yes, that means that the third one